What's new in AutoCAD 2018? First, let's look at the PDF enhancements. In 2017, Autodesk introduced importing data from PDF files as 2D geometry, TrueType text, and images. The 2018 version offers improvements to that PDF import functionality. Now, you can preview your import and scale your import before processing your import. As you can see, the geometry gets converted very literally during the import. But now with the 2018 recognized SHX text tool, we can easily select the geometry and convert to text. Then, with the new Combine Text tool, we can combine multiple text objects into a single multi-line text object for a more polished result. Our next enhancement is object selection. New to the 2018 version of AutoCAD is the ability for selected objects to remain selected even as you pan or zoom off screen. Another area of enhancement in 2018 deals with externally referenced files, or XREFs. Save time and minimize frustration with tools to fix broken paths for XREFs. In 2018, the default path type for XREFs is now set to relative. Keep in mind that the XREF must be located in the same folder as the current drawing for the relative path to function properly. There are two new path options in the XREF palette, Set New Path and Find and Replace. Let's try Set New Path. And now you can also apply the same path to other missing references. Let's try the Find and Replace tool to update references and replace all.
What's new 2018? Autodesk Live.
Today we're going to cover Autodesk Live Editor. Autodesk Live Editor allows you to view your Revit models within a rendered environment, which will help you with virtual walkthroughs, let your clients look and see how materials are against natural lighting and things of that nature. So with the project open, I'm going to cover through several of the basic feature buttons throughout the program here. So over on our left hand side, you'll notice that you'll have your browse button. You can either close the scene, publish to Windows, publish to an iPad, or quit. Now, since we're going to stay in this environment, you'll see right below that on the left hand side, style, which you can change the styles. And basically it's like a shading, color, material environment. And also people. Do we see them? Is it turned on or off? Is the animation on or off? And then how are the silhouettes? Are they transparent? Are they shaded? So on and so forth. Got some gradient as well. Now, below you also have undo and redo arrows. Just like if you were to actually move something, put something in there, you can actually undo and redo your commands as well. It's not just a viewer. Over on the top right, you have a home view button and also additional views that you would have within your Revit model. So if we take a look at some of these, notice how you're seeing that little pointer. What that is located within your settings here, and that settings is also part of how you can mark or create additional views, or those views that are created within your model. Now, for our final area, we will go through our different items within the settings, go over the info, the sun, tap and go, orbit tool buttons. Graphics, which is located within the settings, you can turn on for appearance, which will give you a higher appearance level of the materials, but it'll also run harder. So you could also run performance, which will enhance the speed, but you may get a little degradation on video performance as far as the appearance. With the lights, you can turn on or off the artificial lights that came with the model that you imported in from Revit. Show pins, that's the views that we were discussing earlier. Set height, which would be the height of the person doing the walkthrough. Field of view, and travel speed. That covers everything within the settings. Now, let's say we wanted to adjust what the sun was, the value. All you have to do is left click on the sun, and you can pull that adjuster. Notice how the artificial lights come on when needed. Now, you can also change the date as well, which will also change the lighting and time. Tap and go. This feature here allows you to take and select locations to go to that certain spot. Let's say you're not comfortable with navigating with the cursor. All you have to do is, I'm just going to bring that cursor right over there to that floor, and it takes you through as if you're really walking. That's a pretty nice feature when you're trying to navigate, get around your model there. And then there is orbit. So let's say that you want to orbit, but you can't remember, the combination of buttons or whatever it might be. You're just going to left click and hold down, and you notice how your cursor takes on the same cursor icon as the orbit tool. Alright, so what we've covered here today is how to change out the style, or styles of how your model looks within the rendered environment, how people might look as well, undo, redo, your views or point of interest, and then also your home view. Now, at the very bottom, we covered our settings tools, sun, tap and go, and orbit. Hope this has helped you understand the program of Autodesk Live Editor and enjoy your virtual environments. Have a great day.
What's new in Autodesk AutoCAD Civil 3D 2018? In this video, dynamic offset profiles. New in Civil 3D 2018 is the ability to create dynamic offset profiles. You can create dynamic offset profiles using the same commands that you use to create offset alignments. The profile geometry is offset using default cross slope, which you can modify by editing the profile properties. In this particular drawing, I have two alignments, one for Barrington Avenue and one for Summit Street, along with their corresponding profile views containing the existing ground profile and a centerline proposed design profile. I'm going to create two offset alignments for Barrington Avenue here, one for the 12 foot to the left and one for 12 foot to the right, representing the edge of pavements. Now, to run this command, I'm going to go to the Home tab, under the alignment or the Create Design panel, under the Alignment tool, select that and scroll down until you find Create Offset Alignment. Choose the horizontal alignment, Barrington Avenue, and then once that's done, the dialog box pops up to create offset alignments. Now, this tool is very similar to what you've seen in previous versions of Civil 3D. I'm going to create an offset to the left of 12 feet, and an offset to the right of 12 feet, and I'm going to choose an alignment style of offset horizontal alignments with no label set. Now, new in 2018 is this tab here for creating offset profiles. Selecting that lets me tie my new offset profiles to the centerline proposed alignment. I'll create a profile for each offset alignment based upon the finished grade at Barrington Avenue, which is the centerline design, and I'm going to superimpose this onto an existing profile view. I can either pull down here from the dialog box, but since I only have one profile view associated with this horizontal alignment, I can select it, Or if I have multiple, I can use this button right here to physically choose it within the drawing. I'm going to apply a cross slope from the parent profile of -2%, which represents a standard cross slope for a pavement. I can change this at this time or at a later time in the profile view properties. And then the profile style, I'm going to choose right sample profile for both left and right at this time. I can change that also in the profile view properties. Once this is done, I'll choose OK, and both my left and right horizontal offsets are created. And if I come to this view and zoom in on my profile view window, you can see I have a new offset dynamic profile based upon 12-foot left and right at a -2% cross slope. Now, to show these are truly dynamic, I'll go ahead back in my top-down view. I'll select one of these offset alignments. I'll use the grip to extend the offset out beyond 12 feet. And as soon as I click, you can see that the profile dynamically updates to represent this new distance offset from the center line at -2%. I can also choose the main profile and change. I'll grip edit that PBI and drag it down, and you can see the offset profiles also dynamically update to maintain that 2% cross slope at that offset distance. In this video, connected alignments. New in Civil 3D 2018 is the ability to create connected alignments between two intersecting alignments. Choose your alignment creation tools and select the Create Connected Alignment command. The program asks you to first select one, then the second intersecting alignments, and then a location for the connected alignments. A glyph shows up showing you the resulting location of the connection. If you agree with this, press enter in your keyboard and the dialog pops up, allowing you to change the curve radius, the amount of overlap, as well as a new alignment style and label set, as well as the ability to create a connected profile between the two intersecting alignments. The program automatically chooses the appropriate profiles of the two intersecting alignments that it will make the connection to, as well as a profile style. Once you've changed all your settings, press OK in the dialog box, and the resulting connected alignment is created. If at any time you modify any of the original alignments that the connection was made to, the new connected alignment automatically updates to reflect any changes. You can also select this connected alignment and use the grips provided to modify the connection in any way that you feel necessary. Once this is done, you can also select the alignment and choose a profile view if you created a profile connection. Changing the profile view height to automatic, you can create your profile view and display it, showing the resulting profile of the connection between the two intersecting alignments. And this concludes connected alignments. Thank you for watching. In this video, dynamic corridor extracted feature line as baseline. New in Civil 3D 2018 is the ability to use a corridor extracted feature line as a baseline in my corridor. Now, to provide an example, I have a couple centerline alignments here with corresponding profiles, and I have some simple assemblies here on the right side representing just the lanes, the left and right sidewalk, curb, and daylight, plus a special curb return one. I'm not going to show the curb returns in this video, but I'll show you how to use the extracted feature lines as a baseline. Let's go ahead and create a corridor. We'll call this corridor Barrington and Summit to name after our center lines. Use the basic corridor style. We're going to do Barrington Avenue first. We'll make sure our profile is for our finished grade. In this case, I'm just going to use the full lanes only. And I can pick a target surface, but because there are no daylights in here, it's going to ignore that. I'll set my baseline and region parameters. I'll set my frequency around the curves to a bicurvature. And I'll hit OK and rebuild the corridor. So you can see I have a simple two-lane corridor model running right now. Now we're going to go ahead and extract the feature lines that represent the left and right edge of pavements. To do this, I'll select the corridor. I'll come up to the command Feature Lines from Corridor. Select the corridor region. So we only have one region. We'll say All, and here's the Extract Feature Line dialog box. We'll go ahead and uncheck everything, and I only want to check the Edge of Traveled Way feature lines. If I go in here in my settings, I do want these to be a dynamic link to corridor. Apply smoothing. I'm not going to worry about giving them a name at this time. I'll click OK and extract. You see now as I hover over those edge of traveled ways, you can see that we do have an auto corridor feature line. Let's go ahead and add this left line in as a baseline. So I'll select my corridor. I'll come here to Add Baseline, change my baseline type to feature line, and I'll use the green pick button here to come down and select my feature line. I'll give it a name. I'll say LTETW for the left edge of traveled way, and say OK. I'll now go ahead and add a region to this baseline. Choose my baseline left edge of traveled way. In this case, I will fill the entire corridor run with this region. And this time I'll use the assembly curb and sidewalk left. I'll click OK. Now because this does target a surface, I'll go ahead and add the existing ground surface and select OK. And there you can see it has used that corridor extracted feature line as a baseline. What doing this does is give me more control over how I build my corridor. I can now, if I need to, if I wanted to split this to start creating my intersection, I can highlight my corridor, split my region. I'll choose my region and I'll start my split. Splitting again, region, I'll make another split. I can now go ahead and modify and delete a region. I can also change the frequency of these independently. I'll edit my frequency of this traveled way. Maybe I'll do this every 5 feet instead of 25 feet along the straightaways. So you can see constructing your corridor this way allows me to have more control over how I organize and modify my approach to creating corridors and complex corridor models. And this is it for using a corridor extracted feature line as a baseline in a corridor. Thank you.
In this video, sizing gravity pipe networks. New in Civil 3D 2018 is the ability to analyze gravity networks from within the program. Before performing this, you must have an existing or proposed pipe network in place along with catchment areas defined. To start the analysis, choose the Analyze Gravity Network command from the Analysis tab within Civil 3D. The program will prompt you to choose a pipe network, and the dialog box opens up to let you modify your input. You can see the storm network that was chosen, as well as the outfall choice. Choose the outfall you wish to work with, and enter any kind of tailwater condition you have, as well as options for resizing the pipes and computing energy and hydraulic grade lines. Once you press Next, you can import your rainfall file data. This can be a H&H IDF tabular file, a NOAA CSV, or an X-degree file. After choosing your rainfall file, you can select a storm duration event. Clicking Next, you can now supply input into the structures that lead to the outfall. You have several different choices. In this example, we'll choose curb inlet. Once choosing curb inlet, we must provide information for the opening length in inches, as well as the height in inches. Clicking Next to the next point in the wizard, you can see the data that leads the tributary areas to these inlets. This comes from the catchment area information that you've already provided. If you have any additional flow that you know is going into those catch basins, you can enter that information in the Known Queue tab. Selecting Next, we'll enter any pipe information. It reads this pipe diameter and invert information from your Civil 3D model, and you can modify it at this time if you wish. Click the Analyze button. You can then export the results to a CSV and view in the profile. Once we save it to a CSV, we can go ahead and choose our profile to preview the results. You can see the resulting preview of the calculated invert elevation and pipe size. If this is done, you can go ahead and modify the results if you wish, changing the pipe diameter, the new calculated results, and modify any invert data as you wish. Once everything is done to your satisfaction, you can apply the results to the network, in which case a permanent change is made to your pipe network, showing the resulting new pipe sizes, inverts, as well as the display of the hydraulic and energy grade lines. And this concludes the new Analyze Gravity Network within Civil 3D 2018. Thank you.
In this video, Property Set Data. New in Civil 3D 2018 is the ability to define and use property set data to add extra attribute information to your Civil 3D objects or drawing objects within your Civil 3D drawing. To define property set data, in the Manage tab of the ribbon, click the Define Property Sets button. In the Style Manager dialog box under Property Set Definitions, right-click and choose New and give it a name. We'll call this Utility Information. In the Applies To tab, we'll go ahead and we'll choose objects that this property set data will apply to. In this case, let's choose pipes, pipe structure profile, and structures. We then go to the Definition tab to add attributes that we want to apply for extended information. We'll choose the top button here to add manual property definition. Let's add a field for the owner, and we'll add a field for the SUE level data. Hit Apply and OK. We can now choose objects such as our utility pipes here. Right-click and go to Properties. In our Property tab, under the Extended Data area, you'll see two icons at the bottom that are colorized. One says Add Property Sets. With our object selected, we'll choose the Add Property Sets button. You'll receive a dialog with a list of all the extended property sets available, of which we only have our one we created, Utility Information, and we'll choose OK. You can see that it adds extra information in the Properties dialog box we can fill in with data. In this case, we surveyed this from the surface and did measure downs to provide ourselves with our pipe information. These pipes belong to the wastewater treatment plant, so we'll add that information to the owner section. And because this was ground surveyed with measure downs, this is utility level C in the SUE level, so we'll type the letter C here. As you see now, every time we select an individual part where we've added this, the information does show up. We can use this property set data also in our labels. We have these pipes labeled with our size of pipe, the length, the material, and the slope. Let's go ahead and edit this label style. In the Label Style dialog box under Layout, we'll go ahead under the Contents, select that, and we'll edit the contents. As you can see, there's a new tab here for property set information. I'll go ahead and click on that, right-click on my label composer, and I will type in owner with a colon, add a space, highlight the owner property, and add that to the list. I'll then also add the SUE level, highlight the SUE level information in the properties, and add that to the list.
Once I hit OK and OK on my composer, you can see that property set data can now be used in adding to my labels. This concludes the new information on property set data, and thank you for watching. In this video, corridor bow ties. New in Civil 3D 2018 is the ability to clear corridor bow ties. Corridor bow ties occur when you have a sharp bend and small radius within your corridor to where the assembly overlaps on the inside edge, resulting in the situation as you see in this drawing. We can now clear these out by selecting the corridor, and then contextual ribbon will choose the Clear Corridor Bow Tie command. We'll first select the incoming tangent and the outgoing tangent, and then choose a common location to where we're going to clear the bow tie. Once the area highlighted looks like where we want, we'll go ahead and hit enter, and the bow tie gets cleared. I could then proceed further down station to the next bow tie, run the command again. Again, I select the incoming and the outgoing tangent and select the common vertex location. Click enter, and the command continues. In order to modify an alignment or modify a radius, we must restore the corridor bow ties to their original condition. To do that, we select the corridor, choose the Restore Corridor Bow Tie command. The bow tie to be restored highlights. If we want to restore this, we just hit enter and hit enter again, and the bow tie resumes to its normal original condition. We can now modify the radius or modify the alignment, and if need be, we can go back through and clear the bow ties again. There's also a situation where we're not tying into an existing surface, or maybe where we don't have a radius and have a sharp corner, where we can automate the process. So as we build the corridor bow ties are automatically cleared. To do this, in our settings window, we come down to the corridor section, right click, and choose Edit Feature Settings. You can see we have a new setting here for automatic clear bow tie options. Expand this and choose a value of yes for tangent-tangent intersections or tangent arc intersections. When you create your corridor, these types of bow ties will automatically be cleared. And that concludes the section on clearing corridor bow ties. Thank you for watching. In this video, COGO Traverse Adjustments. New in Civil 3D 2018 is the Traverse COGO Point Editor and Adjustment. Here I have a drawing where I have some COGO points that were brought in from points shot in the field. It runs number points 1 through 5, where 5 is my closing point on 1, and you can see we have a little closing error here. To use the adjustment features, first we need to create a traverse file. On the Home tab, under the Create Ground Data, you'll see this traverse command. Selecting that in the pull-down menu will first open the Traverse Editor. This will add a new window to your Civil 3D where we can input a traverse. We can input points and lines, points or just lines, and also lines and arcs, depending on our situation and the traverse we're entering. I can also use this command, let's say if I'm entering data from a plat, or I want to create my figure within Civil 3D. Since I have points already in here, I'm going to start with my side and the first point. The original occupied point is point number 1, and as soon as I enter that, it adds a new line to my traverse editor. I then have the option of adding either a line, a point, an arc, or a side shot. I'm going to continue choosing points. I'll add my second point, which is point 2, the next point, point 3, 4, and finally point 5. If I added line or arc information instead of point information, on the right hand side under COGO point, it would go ahead and create new COGO points as needed as I enter my lines and my arcs. Once everything is input, I go ahead and I save this file. We'll call this Traverse 1 and save it. You can also see as I've added my points, or if I added lines or arcs, it draws the figure and labels it appropriately. These are temporary graphics, but I can make the choice of whether I want to keep these permanent or not. To make the adjustment to this traverse, I'll go back to my Traverse pull-down command and I'll choose the Traverse Adjustment tool. This opens up a new dialog box. The first thing I'm going to do here is select my original TRV2 file that I saved in the previous step. Once I open this, it fills out the table with all the different data, including my starting point and my ending point and my point of closure. It made this assumption just based upon the traverse I entered. If there was a different point of closure, I would go ahead and choose it from the points that were entered from the file. In the closure summary area, it shows me my input precision, my distance, and direction of error of closure, plus the different types of closures depending on the type of adjustment I want to do. It gives me all the values for the different nominal adjustments, and if I want to apply a particular one, let's say transit or compass or crandle, I would make the choice here. Let's do a compass adjustment, so I'll leave that the same. I can go ahead and generate a closure report, or once set, I'll just say apply adjustment. It's going to ask me to save a new TRV2 file, Traverse 1 Compass TRV2, and save it. Once this is done, I can close the dialog box. And back in the Traverse, I'll go ahead and I'll open that new adjusted TRV2 file. As you see, once I open it, I get the new point information, and it's created a new set of COGO points for the adjusted traverse. And that concludes the creation of the traverse and the adjusted traverse tool. This concludes the COGO point traverse creation and traverse adjustment tools, new in Civil 3D 2018. Thank you for watching.
In this video, relative elevation feature lines. New in Civil 3D 2018 are relative elevation feature lines. You can obtain feature lines from a surface or relative to a surface, so feature lines update with changes to the surface. In this drawing, I have a model of a proposed parking lot. In the background, I have a reference surface that I'm using to add a constant grade and flow to the parking lot, and I have some other feature lines that are draped on it. Now I'll go ahead and create feature lines out of these two islands, and I will drape them on the reference surface, but I'll show you a new feature where you can say I want these feature lines relative to a surface. So I'll highlight a feature line. In my command line, I'll say feature line, create feature lines from object. I'll go ahead and assign elevations. When I hit the OK button, it's going to ask me which surface I want them on. So I'm going to elevate them from the reference surface. And new in 2018 is this button to say relative elevation to surface. Since this is going to be the edge of pavement, I'll say 0 feet, and I'll go ahead and create that feature line and drape it on that reference surface. I'll then click the other line that represents the top back of curb. I'll create a feature line from that object as well. Run through the same procedure, except this time I'll say relative elevation to 0.5 feet. Once those are created, I'll highlight both of those. I'll add those to my final top pavement surface, and it will update the surface. I'll go ahead and rebuild my surface. As you can see, I have my surface and that island has been added. Now what makes these special are, now that I can go back through, and this feature line represents one of the feature lines from my reference surface. Right now, I have a grade of 2%. If I wanted to raise this to say -3%, you can say not only did that feature line change,
but also those new feature lines that I said to be relative to that reference surface, they also modified along with it. Again, if I make a change in the other direction, maybe minus 1.5%, those feature lines moved along with it, and my proposed top surface also changed. In another example, I have a drawing here with a corridor of a retaining wall that was created along a feature line. New in 2017 was the ability to create corridors along feature lines. So if I change this grading here, and this feature line here has been created and it's been set upon this surface that's been created from this grading object. So if I highlight my grading object and I go ahead to my edit the grading, its current cut slope is 3:1. I'll change that to, let's say, 6:1. And my fill slope also to 6:1. As the grading changes, notice that the feature line also adjusted to that new surface, and the retaining wall has automatically adjusted to that feature line. So that's new. It's an awesome feature, and I hope you get some use out of it. Relative elevation feature lines. Thank you for watching. In this video, plan over plan and profile over profile plan production sheets. New in Civil 3D 2018 is the ability to create automated plan over plan or profile over profile plan production sheets. In previous versions of Civil 3D, you could only make a single plan, single profile, or a plan over profile production. If we look at our plan over plan production template, we can see that the viewport, similar to previous versions, we could identify the viewport as either a plan, profile, or a section viewport. But now we have a new property, whereas we can add the viewport order. In the top view, you can see here, top viewport, it is viewport order 1. And the bottom viewport is viewport order 2. So back in our drawing, we can create our view frames. We select our sheets and make sure, in this case, we're going to do a plan over plan. Choose the plan only section and make sure we browse to the proper template that contains a plan over plan view frame. We'll choose the ArchD plan over plan 20 scale. Select OK. Go to the next. Match lines. We'll align our match line labels to the middle and create our view frames. Now we can create our sheets. Go ahead and make a new sheet set and create our sheets. The drawing will save. It'll save the drawing, do the progress, and let's go ahead and look at our sheets. Here we can see we have a plan over plan, sheet 1 and sheet number 2. The same process can be used to make a profile over profile set, or you can still use the traditional plan over profile. That concludes this section on what's new on Civil 3D 2018. Thank you.
What's new in Revit 2018? Let's focus on the new Revit platform features, functionality, and enhancements. 2018 introduces Revit users to the new coordination model tools found on the Insert tab. This new feature allows us to link Navisworks models directly into our Revit models for better visual coordination. Any file format supported by Navisworks can now be brought into our Revit world. Coordination models appear in all views, just like Revit links, but they render using the native Navisworks engine, which supports a shading display. Similar to Revit links, these coordination models can be positioned by origin or shared coordinates, loaded and unloaded as desired, and pathed via absolute or relative path types. Also new in 2018, available schedule categories have been expanded to include Revit links and model groups. With this functionality, users can generate lists of all their links or model groups in a project to easily review and monitor their properties and enhance their overall project organization. 2018 also makes available the addition of radius and arc length dimensions to global parameters. This expands the usefulness and control afforded by global parameters. With global parameters, the parametric qualities of the family editor are made available directly in projects. This allows named constraints to be applied to distances and parameters. We can define critical hold dimensions and flex labeled dimensions. Text notes in 2018 now support the full character map for any installed font. This means you can now add symbols directly in text notes. What's new in Revit 2018? Let's look at the new features of the architecture tools. Revit 2018 includes many enhancements of the multi-story stair creation and modification tools. Attach your stairs to levels. When level heights change, your multi-story stair will automatically adjust. Stairs are grouped by level height. Unpin a stair to remove it from a group and modify. These multi-story stair features make the process of creating complex stair towers simplified. Railings for multi-story stairs have been enhanced too. Hosted railings recognize the slope of their host automatically. Railings can now be hosted to a topo surface element, which makes it possible to finally add common site conditions like fencing or handrails with the railing tool. What's new in Revit 2018? Let's look at the new features of Revit MEP Design. 2018 introduces users to the ability to create custom building and space types to suit project needs. Historically, these building and space types have been a hard-coded list, but now you have the freedom to build and name and tailor your own types. Additionally, space and building types now include outdoor air requirements in an effort to provide a better mechanism to compute energy estimates and better simulations. Also new in 2018 is the Edit Path tool for circuit design. Revit now enables designers to define the intended circuit pathway for downstream analysis. Insert control points to add or reroute a segment of the circuit path. This control over the pathway, and thus the length, is a critical input to the computation. A more accurate route of the circuit path means better analysis and design. What's new in Revit 2018? Let's look at the structural enhancements. The rebar tool has been updated. Also new to 2018 is the ability to place rebar in imported concrete elements from SAT files or Infraworks. Rebar logic can now be edited in 3D views. Place rebar in complex geometry by sketching a rebar shape along the cover. This enhancement to the rebar functionality increases rebar modeling versatility and accuracy. Moreover, rebar constraints can be set, thus allowing the rebar to react to its concrete host's changes. Next, let's take a look at the new features of the Steel Connections tool. Users can now set the primary element and the order of the secondary elements within steel connections. Secondary elements are displayed as numbered circles. This enhancement provides designers with greater control of their steel connections. The steel connections for Revit add-in has over 100 new connections. 2 new categories have been added: purlins and cold rolled, and miscellaneous. The 6 existing categories have also been extremely expanded. These structural enhancements provide greater control over modeling of steel connections.
What's new 2018? Navisworks Manage.
My name is John Ofield, and this time we're going to be covering Navisworks Manage 2018. So as you see, with the program open, it's blank screen, but the availability to open up multiple file types is very easy. So what you want to do is typically you'll either open or using the open folder, or you can use append as we see up here in the top left ribbon. We're going to select open for the central file, and in order to add other files as in a structure, you can use the append button. We can just select all of those additional files and select open here. Now you can see the entire model has been built. So that is working with file structure, appending files from the main file, and that way you can easily track these as well. So if we were to open up what's called selection tree right under select and search, you'll see that we have all of our files here, and they can be expanded out. So that's dealing with the files. Now with 2018, there isn't really too many more new tips and tricks, but there are some features as in using page up and down, and this will allow you to zoom back and forth. You can also use the Alt key and the Control key with your wheel to change your orbit and selection there. Now another thing, if you need to orbit, you can hold down your shift and the wheel of the mouse, and you can see that spin there. It's just easy orbiting, but you can also use the view cube as well. Now if you get lost where you're at, you can always click on the little home and that'll take you back to originally where you were. Now let's take a look at rendering. Rendering can be done, as you see here. We see that it's on shade color view, but if we want more of a rendered view with materials, you'll want to select the render tab. The render tab will allow you to use the ray trace engine within Revit, within Navisworks. You can select the down arrow. You can pick low, medium, high, coffee break, lunch, overnight, and this is utilizing your machine, not actually the cloud. But as you see here, if you do have any cloud credits, you can use the rendering cloud as well. So let's go ahead and use the low quality ray trace, and this is live as well, so if you zoom in and out, it'll actually have to retrace all of that rendering capability. So see, if I zoom in here, you'll be able to hear the video card as well amplify, and then you'll see that the rendering does keep up. So if you did an animation with the rendering on, it also helps that way. Let's go back to our home tab. If you haven't used selection sets, then let's go back and see what selection sets can do for you. So let's say we're back in our selection tree and we want to select maybe every other file, and that could be because of maybe certain items in each file are the same. Could be because that there's piping in two of the files, like the east and the south file here. Well, what we could do is save that selection set, and we could call this the MEP project files. Whereas the others, maybe it's north and west, we're going to call that the telecommunications. So you can select save selection, and there we go. So with that, you can also utilize this in your clash detection. So if we're to turn on clash detection, you can run file against file. You can expand your files, run against objects if need be. And then also you can use your selection sets. So if we select where it says standard here, select sets, now all of a sudden we can run multiple files against themselves and not even have to go back and reselect everything. Selection sets can really come in very handy on that portion there. So what we're going to do is just simply grab a quick set here off of the standards. That way it's not running as fast. And we'll select run test. Now this is very basic, but you notice that you can add tolerances, hard clashes, soft clashes, imposed insulation, things like that. So as you see here, the clashes are piling up, running to the test, give you an actual percentage of what's being done as well. When that finishes, it's going to give you those highlighted green and red by default. Now you can change these colors, but by default that's what they come up as. So with that, you also have up here at the top, those are the new clashes. Active, reviewed, approved, resolved are what happens along the process of the collaboration review. You can left click on each one of these and it'll take you to each one of those particular clashes within the project. Notice it also has the date and time. You can change these to active, reviewed, approved, resolved, and notice how it changes the color as well. Coordinates with the above. So besides that, you also have the properties information. Properties will tell you a lot about those objects. If you select those objects, it tells you where it came from typically, like this is AutoCAD, and if it's in the timeline or for simulation. Now with simulation, you can actually coordinate the project being built, materials being brought in, things of that nature, to where you can actually add cost and see if certain things match or if they need to be changed when they're being brought into the project. You can use that with multiple items. You also have what's known as quantification. Quantification will run through, quantify all those components, and you can set up values for that and run the quantification analysis to give you pricing and things of that nature for your project. Well, I hope this has helped you out with some of the basic items and the fundamentals of the project throughout Navisworks. Thank you. Have a good day.
What's new in Autodesk Infraworks? In this video, new Infraworks component road features. New in Infraworks 2018 is the ability to convert stylized roads into component roads, all with a simple click. Simply select your stylized road, right-click, and choose Convert to Component Road by Automatic. It's easy and it takes just a few seconds to do. Also included in the new version of Infraworks are fixed increment station labels that display for the selected component road. They move and vary depending on zoom level
in both the horizontal and the angle view for vertical and profile geometry. In-context messages provide instant feedback for the roadway curve and spiral layout, providing you length and radius, as well as a contextual area where you can change these components, providing instant feedback and easy design changes. When modifying a roadside grading section, a new improved gizmo makes it easier to drag the start and end locations to change and split the grading into a section. You can then select this section and modify that grade independently of the remaining grades of the road. Once complete, you can select the other sections and add transitions to blend your new grade slope in with the rest of the existing model, offering you the ability to provide a nice visual appeal and blended appearance to your grading. What's new in Autodesk Infraworks? In this video, computing quantities. In previous versions of Infraworks, you are already able to calculate earthwork quantities, creating reports to view your cut and fill volumes by station, including key geometry points and total net cut and fill. New in Infraworks 2018 is the ability to calculate quantities, including drainage structures, culverts, road surface items, and city furniture used as decorations. You can export these to a CSV file, which can open in any spreadsheet program, giving the ability to print a preliminary report of quantities for your design. For more information, visit our website at www.seiler-ds.com. In this video, Infraworks visualization updates. New in Infraworks 2018, the engineering view is the default design view, giving you a clean design area. Switching to the conceptual view gives you better visual appeal and a more realistic appearance. To improve performance, you can modify this view and turn off realistic trees, giving you a more simplified look with a translucent tree increasing performance. Also new in 2018, the display of in-canvas annotations transitions smoothly when you change the view. When using the measurement tools, such as point-to-point distance, you'll see improved labeling for the length and area information as you move your view around. In Infraworks 2018, there are two new adaptive tree styles, the spruce tree and the spruce tree with snow. They join the beech tree for more realistic views. These adaptive tree styles alter their appearance, giving more detail when zoomed in and less detail and more performance when zoomed out. For more information, visit our website at www.seiler-ds.com.